Right, so we're looking at a normal distribution exam question. Okay, so the heights of a population of men are normally distributed mu and sigma. So we don't know the mean or the standard deviation. Heights are distributed normally with mean mu and sigma squared. Okay, and we're told 20% of men are taller than 180 and 5% are shorter than 170. A sketch and diagram shows this distribution of heights represented by this information. So A, look at that, they've even asked us to sketch. So what's going to go in the middle? Well, we know that mean goes in the middle. We don't know what that is, mu. I'm going to put sigma equals sigma here just to remind us what the standard deviation is and we don't know what it is. 20% are taller than 180. So 180 is going to be up here and this is h and that is 20%. And 5% are shorter than 170. So down here is 170 and that is 0.05. Okay, so that's what we're dealing with here. Find the value of mu and sigma. So we've essentially got two pieces of information. And we've got two unknowns. So simultaneous equations. So we've got, two pieces of information and two unknowns, so it's going to be simultaneous. Now underneath this, I'm going to see if I can get it all on one picture. We're going to have z, and in the middle of there we've got 0, because z is distributed normally mean 0 and variance 1. So we're going to want to find these two z values. So for this one, I'm going to use the inverse normal function. And the area I'm going to use as 0.05. Let's do it here, just using my calculator. Menu 7, inverse normal, area 0.05, sigma 1, mu 0, and then equals, and it's going to give us a z value of minus 1.64485. So that's minus 1.64485. This one here, and do here, again, inverse normal, but this one's going to be area. And remember, it's to the left of, so if that's 0.2, I'm going to use 0.8, 1 minus 0.2. There's a bit of work in there. Again, sigma 1, mu is equal to 0, and z is, hopefully it's going to be positive because it's to the right of 0. So let's go back into this and put an area of 0.8. Everything else is the same, and I get 0.8416. 0.8416. What I should have done actually when I did this, I'm going to store that as B, so store B. I'm going to go back and store the other one as A. So store A. So I'm going to store that to A, and I'm going to store that to B, just a little calculator trick. And then what have we got? We know that Z is equal to h minus mu over sigma, and z is equal to h minus mu over sigma. Okay, so we've got minus 1.64485 is equal to h here is 170 minus mu over sigma, and this one we're going to get 0.8416 is equal to h 180 minus mu over sigma. So we've got two equations now. We can solve them simultaneously. So I'm going to multiply through by sigma, minus 1.64485. Sigma is equal to 170 minus mu, and this one is 0.8416 is sigma is equal to 180 minus mu. Now I'm going to write this one under this one. So minus 1.644, and we're going to solve them by elimination. If we take them away from each other, the mu's will cancel, and we're going to get left with 10 here. I'm going to use the calculator for this, and I'm going to do, what is it? It's going to be B minus A. Alpha B minus alpha A. And I'm going to get 2.48647 sigma. Divide both sides by that and you get sigma is equal, so 10 divided by answer And then there's no need to write loads of numbers down 8 when I round it. Then we can substitute that back into, say, oh, hang on, let's get an answer. There you go. Substitute that back into here. And we'll get mu is equal to 0.8416. I'm going to store that as C. Store C. Again, just trying to use the calculator as effectively as possible. Times sigma, which is C. It's going to be 180 minus that. 180 minus that. So 180 minus, what's that? B times C. So mu is equal to 176.615. Does that match with the picture? Yeah. So what I typed into my calculator here was 180 minus BC, because I've stored that's equal to B and that's equal to C. I've said up here actually, haven't I? Okay. Right, that's done. Okay, so then that's B. What's C? 3 men are selected at random. Find the probability they are all taller than 175. Okay, so C, let's do in here. So what's the probability that one of them is taller than 175? Probability that H is taller than 175. Well, we know the mean is 176.615. So it's going to be this, isn't it? That's 175. And we know sigma is equal to 4.0218. So we can put all of that. Now we're going to use menu 7, just normal CD. So use normal CD. Lower is 175. Upper is something big, 10,000. Sigma is, I wonder if we can just put in C, alpha C. We can, because I've got sigma as C there. C, mu is equal to 170, was it? What's mu equal to? No. Oh, I never stored that. Oh well, so I'm going to have to put that in, 176.615. 176.615, and we get P is equal to 0.65599. I'm going to store that now. Store D. That goes to D, and then all of them are taller than that. So it's going to be that probability all three bigger than 175 is equal to D to the power of 3. So I'm going to come out of that and go menu, go back to calculator, and then put D to the power of 3. I'm literally going to write that in my calculator. I get 0.2823.